transform of t square cos t, Laplace transform of t square cos t, and the solution to this is, first you have to recall some few formulas, and the first one is you need to recall that the Laplace transform of cos, that is the Laplace transform of cos t, is simply equivalent to, this is simply equivalent to S1, and also that you recall that the Laplace transform of t to the power of n cos t is given by this formula. This is negative 1 to the power of n. The nth derivative with respect to s of s over s squared plus 1. So therefore, you can simply say that Laplace transform of t square cos t is equivalent to negative 1 squared, second derivative with respect to s of s divided by s squared plus 1, and this is simply equivalent to d over ds of, you hold the denominator constant, that is s squared plus 1, multiplied by the derivative of the numerator with respect to s. You subtract your denominator constant, you multiply by the derivative of the denominator, that is s squared plus 1. You divide everything by the square of denominator, that is s squared plus 1, everything squared. Now, so if you compress this down, this derivative here is 1, so this is d over ds of s squared plus 1 you subtract 2s squared, that is, if you differentiate this part, you divide everything by s squared plus 1, everything squared. So in other words, the numerator can be written as, so this is d of ds, the numerator is s squared minus 1, then the denominator can be written as, and let it remain the way it is, this is s squared plus 1 squared, or this denominator, let's say they can be written as s power 4 plus 2s squared plus 1. So from there we differentiate again, that is d of ds, this is s squared minus 1, s power 4 plus 2s squared plus 1, and this is equivalent to saying that you hold the numerator constant, and this is s square plus 1. Sorry, what the denominator constant in this form. Then you differentiate the numerator, s square minus 1 minus, you add the numerator constant s square minus 1 d of ds of s power 4 plus 2s square plus 1. You divide everything by s square plus 1 into s square plus 1, everything cubed. So this is to say s square plus 1, s square plus 1 multiplied by 2s minus s square minus 1 multiplied by, if you differentiate this part, this is 4s cubed plus 4s. You divide everything by s square plus 1 into s square plus 1, everything cubed. And from that we can simplify. Or before we simplify, we can collect the like terms, whichever way. So this one will cancel out with this, and then you remain with 2s into s square plus 1. You subtract and before we go to this point, before we even simplify, we can factor out what is common. So we have s square plus 1 into 2s into s square plus 1. You subtract 4s into s square minus 1, close the bracket, then s square plus 1 into s square plus 1 cubed. So we have this cancelling with that. So disregard this point, disregard the simplification on this part. So now this now becomes, this is to say we have 2s cubed plus 2s minus 4s cubed plus 4s, everything divided by s square plus 1 cubed, and this can be compressed down to become minus 2s cubed, the 2s cubed minus the 4s cubed here, that gives you minus 2s cubed plus 6s. You divide by s square plus 1 cubed, and again this can be written as 2s into s, 2s into s minus 3. You divide by s square plus 1 cubed, and therefore the Laplace transform of t square cos t is equals to 2s into s minus 3 divided by a square plus 1 cubed. And that's all. Thank you. Kindly remember to subscribe, share, like, view, and comment. Tell a friend to tell a friend. Thank you. Bye bye. Bye bye for now. Until next time. Thank you very much.